Okay, so now that we have seen the theory of this course, we will move to practical examples. So let's put together the Arduino and the breadboard and build our first circuit. First of all, let's explain a little bit what the circuit will do. We will start with a basic example, like a light LED with a push button. So this circuit will control the LED by pushing the push button. Here in the right, you can see the schematics. We will analyze later. And first, let's see the material we need. Quickly reminder that all this material is included on the kit that I said before. So we will need an Arduino Uno, a breadboard, an LED, color whatever you want, one 220 ohm resistance, and 1 kilo ohm resistor. Then a push button to turn on the LED, and some jump wires to power the LED, power the button, and for the digital signals. So once we have all the material ready, let's mount it, and then we will start programming. Okay, so we can start building our first circuit. With the list of materials that we have seen, we have the Arduino Uno, the breadboard, some jump wires, the LED, the color that we prefer, a 220 ohm resistor, 1K ohm resistor, the push button, and so we can start. First of all, we want to power the breadboard, so here we have some different voltages and the ground pins. So what we will do is connect the red jump wire to 5 volts and then to the red line of the breadboard. So now we have 5 volts all along this line. Also, we will connect the ground to the blue line, so we have ground all along this line. As we have seen in the previous slides, this is not shared, so the top and the bottom are not shared, so this red line here has no voltage, and also this blue line here has no ground. If we want to share the lines, we could, for example, connect with jump wires or to Arduino. Then we will move for the push button. You can see here that it has 4 legs, but the legs that are next to each other are internally connected, so the bridge goes from bottom to the top. So when we push, the current flows vertically. So this helps us to connect the button this way. So this means that we want to connect the power or up here, and then the digital read here or reverse. We will connect, for example, the pin here and the 5 volts and the ground here. So in one of the legs we put the 1K resistor to help have a clean signal, and then a jump wire to read the 5 volts. At the other side, in one of the legs, as I said, we can choose if this column or the other, because are connected. We will connect it to one of the digital pins of the Arduino, for example, pin 7. We can change this, we can choose a digital pin that we want, but remember to, in the programming section, set the proper value. So for now we have the push button powered. So here there it comes 5 volts. If the push button is not pressed, the 5 volts flow through the resistance to ground. So this is a closed circuit. And if the push button is pressed, the 5 volts will go through the digital pin, so the Arduino will be capable to read. Then last step is to connect the LED. The LED, as we saw here, we see here, it has a positive and a negative legs. This is the anode, this is the cathode. So this means that we cannot connect, well, this means that we cannot connect the short leg to power, because this works like a diode, so the current won't flow. So we connect the LED. Remember that, for example, we can connect the longer leg in the right, and connect to the longer leg the jump wire that will go to the Arduino, for example pin 8. So the Arduino will provide the power to the LED, and then we finally add the last resistor, the 220 ohm resistor, from the short leg to ground. This also closes the circuit. So here we have our first circuit. So we now move to program it and finally test it. Okay, so we start programming the push button example. We will try to go a little bit faster to get some practice. As we've seen, we will define the pins here that we have connected in the assembly. So what we are gonna do is use a constant integer pin definition, for example for the button pin, and now we look at our Arduino, at our circuit, and we see that we have connected the button to the pin 7. We do the same for the LED, in, and now we look back to the circuit and we see that we have connected the LED at pin 8. Perfect. We will go now for the setup. We need to set these pins. So using the command pin mode, as always, you call the button pin and we have to set it as an input, but this time with pull up, because we added the 1K resistor. This helps us to have a clean input readings. We do the same for the LED. We write LED. If we here, for example, we press Control spacebar, this helps us to autocomplete the code. This is quite interesting to gain agility. For example, and we can go faster. This time we want to also open the serial. We do the same, for example, serial again at 9600. And okay, this is perfect. We could also add a serial print here that informs that all is set. For example, setup done. Let's go for the logic of this example. Perfect. So we move to the logic of this code. What we are going to do is now understand what we want. As we explained it, as in the slide and in the mounting part, that we want to read the state of the push button. So as it is a push button, it only has two states, pushed and not pushed. So we want to save this state and then apply some conditions. To save this state, we are going to do a variable declaration, for example, called button state. In this button state, we want to save the digital value of the button pin. So we want to read what's going on in this pin, the pin 7 of the Arduino that is connected to our push button. To do this, there is a command in Arduino called digital read that we can select the pin that we want to read, and here we will have every iteration, every time these loops repeat, a value refreshed of the state in the button pin. This, as it is a digital, it will return a high or a low. So, for example, if the button state is high, we want to do something. In this case, turn on the LED. So, to do this, translating this logic to Arduino programming, we use the if sentence. Wait, this is not properly intended. Oh, that's it. So, as I said, we want to check if the button state is high. Because if the button state is high, this means that the push button is pressed. So if the push button is pressed, we can use the same function as we saw in the built-in LED example, that is turn on the LED using a digital write command. How we turn on the LED? As we saw also in the last example, then we select the pin and the value that we want to set. In this case, height. Also, as we have opened the serial, we want to the Arduino provide some feedback. So he's turning on the LED. Perfect. But this is not always the same case. If we do this and stop here, the LED will always be pressed because the LED, sorry, will always be turned on because we are not turning on off the light once the button is not pressed. So we need another else condition. So if this is not happening, it means that this must be happening because we have a two-case condition. So if the button state is not high, it must be low. This means that we want to set or LED pin low. You can copy this, for example, and only change this. Perfect. We check, a quick check here. We have defined the pin variables as we use it here in the pin mode definition. Button pin with input pull up because we added the 1K resistor to close the circuit if the button is not pressed, to have a clean digital read. Then we have the LED pin defined as an output because we want to power the LED, so the power goes from Arduino to the LED. So this means that is an output. We open the serial communications at this speed, that is the standard one. We check that is all setup done. And then we start the logic. We read from the button pin. We save the state in this variable, and we check the two states in these conditions. So we can verify the code. All perfect. So now we only need to connect the Arduino. So the code is properly sent. We can open the serial monitor. We see that it's always printing that the LED is off. And if we press the circuit, it turns on. If we keep the button pressed, it stays on. And then goes to off. Let's check the physical circuit. So let's have a quick check here. Remember the resistors to ground, the button powered, and we can see that if we press, the light stays on, we leave, goes off. This is our first circuit, our first example of the course with all this setup, so we can move to the next one.